So, hello everybody. This is a small session which is giving the overview of a course which is 30 hours in SQL Server, Advanced SQL Server course. It's a small introductory video about this course and the faculty who is going to take this course, which is me. My name is Arun. So let me just first introduce the objectives of this course, and then I will come to my introduction. So the objectives of this course is basically, first, who is going to be the audience for this course? The audience for this course are people who have been working in SQL Server for at least 5 to 10 years, because they need to have basic knowledge of coding in SQL Server. Also know different features of SQL Server. So this is the bare minimum requirement of a person who is going to attend this course. What are the objectives that I have set for this course? You have SQL Server commands. So you might have done the basic commands, select statements up to joins. Then you have commands like insert, update, delete, right? So these commands you might have dealt with. We are going to see certain commands which are a little advanced in terms of certain T-SQL commands which give additional features to the basic feature of writing query, insert, update, delete. So I'm going to give the example here that I have. So typical example, one of the features that I will be explaining is the windowing function. So we will see when we come to that topic. So which is called a function which is going to be working on a window of data. So we will talk about it. So we are going to see certain advanced T-SQL commands like windowing operations. Then this session will be theory combined with demos. Then we will have sessions on SQL Server physical architecture. Okay, so the physical architecture of SQL Server. Here we will be looking at what are the layers of SQL Server architecture. Like we have the base OS, then you have the SQL Server OS, and then you have different processing engines, like you have the query processing engine, and we also have different engines for I/O, disk I/O. We will see in detail. The second the second topic is going to be theoretical. So we will see views, and we will see how the views can help us give insight into the architecture of SQL Server. Then we will see the table structure in SQL. So we will see how data in table is stored, what is going to be the three ways in which data is stored. So one, using heap data, there is no indexing. Then one using heap data with indexing, and the other one is data which is structured using indexing. So we will see different table structures. Then we will see locking and concurrency. When you use SQL Server resource, many simultaneous processes can be using the SQL Server resource. And when the SQL Server resource is being used, that time there should be no clash. There should be no inconsistency in transactions. Therefore, we will see locking and concurrency. When we see locking and concurrency, we will also talk about transactions. We will also finally talk about query execution plan. All of you might have executed different queries. We will see how to read the execution plan when you're writing your query and find out what the execution plan is going to communicate, and then optimize your queries to reduce the time of running these queries and fetching the data. So the result should come as soon as possible. So we try to optimize the query. We will see query optimization. These are the topics that are planned for advanced SQL Server. What is the duration planned? The duration planned is 30 hours. And every topic will have theory session with demo, except for the topic of architecture, because the architecture is just describing what SQL Server is. There too, we will see if we can get an insight to the different data structures, the different layers of SQL Server using certain views. We will see how that can be done. This session is going to have medium of communication as English. This is an English session. So as I said, what is the prerequisite expected of the participant? The participant must be well versed with basic SQL Server commands like select. And in select also we have so many variations, having aggregates, having and raw filtering, aggregate filtering, then joins, different types of joins that are there, subqueries. So these are the bare minimum T-SQL, bare minimum, you can say commands that one should know. Join is a command one should know. When you're writing a select statement, we should know that there is something called subquery and how to use it. And these are some basics that one should know. Insert, update, delete, one should know. And to go beyond this basic, we will have certain T-SQL commands that we will see here. There are T-SQL commands which are standalone for insert, update, delete, select, new T-SQL commands. There are certain T-SQL commands for a specific feature. Like there is a feature called partitioning, table partitioning, horizontal table partitioning, or horizontal data partitioning. For that, what are the commands? We will take a look at. So as I said, we should be well versed with logical architecture of SQL Server. So one should know what is the starting point of SQL Server. What do we mean by SQL Server instance? How do you connect to SQL Server instance? Then what are the databases, system databases in SQL Server? Then how data is stored logically in SQL Server file groups. This basic one should have. So what are the system databases? What are their functionalities? One should know. Then participants should also have hands-on experience on SQL Server development. This, as I said. Now I introduce myself. My name is Arun B. I worked for 17 years in IT industry as consultant and trainer. And I have been dealing with topics of SQL Server development, performance tuning, SQL Server BI, like SSIS, SSAS, SSRS, data quality service, Power BI. These are the topics I have been dealing with. Then when I started my career as a consultant in IT, I also used to deal with C++. I have dealt with .NET architecture using C#, developing .NET applications. SharePoint development also I have done. Then core design patterns. There are a gang of 4 design patterns. The 24 design patterns are discussed. So, and are then also applied while you're coding. So this is the background that I have, and I continue to work as IT consultant. Okay, let us see the individual. So now I have given initially the overview of what are the topics that are going to be covered. Now in each of these topics, you will have a, the subtopics. So I will just discuss briefly the subtopics so that you are clear what we are looking at. So when you are looking at advanced T-SQL features, the T-SQL features are also related to other features. So T-SQL command related to other features. So there is a feature called change data capture, which is going to capture the changes in the data using the SQL Server log. So you should know what is a log file from the basics because that is one of the prerequisites. So using a mechanism, we capture the change in the data using SQL Server logs. So we will see all the T-SQL commands that are required when we are using change data capture. Then we see common table expressions. So all of us have used select statements. And when we are using subquery in the from clause, it is called derived table. There, the table is stored in memory till the entire query is executed. So the derived table now is converted into what is called as common table expressions. So we can write select statements which will give the output, and the output of the select statement can be used in subsequent select statement in a single batch. There are many challenges one faces. Like for example, in the same result set, I want to see what is the order or which is the product with maximum number of orders and minimum number of orders. When we try doing it using the select statement that we know using subqueries, it is quite complex and its execution also takes time. That is going to be modified, or that can be modified by using common table expression. So we will see what is common table expression. I'm not giving any demo right now because it will be part of the session. Then we will see what is unpivot and pivot. All of us have seen the data. You have two-dimensional data, you have x-axis and y-axis. How do we convert y-axis into x-axis and x-axis into y-axis? So this is a typical, you can say the typical feature which will help in reporting. Then we will see table partitions. Table partitions are very useful because if you do not partition a particular table, so here horizontal partitioning of data is what we talk about. So when you create tables, we will normalize the table if it is used for OLTP or online transaction processing. When you normalize the table, that is called vertical partitioning. So you have a lot of columns and you create multiple tables for different columns based on certain normalization process. Here we are talking about horizontal partitioning. Let's take orders data. If I store all the orders data in one particular file, then the system has to lock that file when somebody is accessing the data from the table. That gives a lot of strain on the resource. And not only that, it locks a major chunk of data. Whereas in horizontal partitioning, one table data is stored in different physical partitions, in different physical files, in different physical file groups, so that when I am accessing data from one partition, the other partitions are available to be accessed. So it's called horizontal partitioning. So we will see different mechanisms, and there is a mechanism called sliding window partition where the partition keeps changing. And this becomes especially important when we are analyzing the data using SSIS, loading the data into OLAP database. At that point in time, reading data from a particular partition and loading the data into the OLAP or online analytical processing unit, it becomes easy. So that's why table partitions are there. So we will see all the T-SQL features related to table partitions. Then we will see window function. Rank function I will come to. Now, I just wanted to explain this bit because I wanted to show some demo. So let me go to this demo. So all of us know that we have different functions which are given by SQL Server related to different data types. So here I have a function where I am giving year-wise, month-wise total due. And total due that needs to be paid from a table called sales order header table. So now when I execute, the data executes and it is going to give me a result. It takes some time. Now, whenever the data is executing, you can see that this function year operates on the entire table sales order header. Now, when it is operating on the entire table, at a time, it operates on one row, one value. So this one row, one value becomes the window of operation for all the years. I'm just stopping the query. The query is taking a little longer time to execute. So the window of operation for year that is available is complete set of rows. So what is a window? A window is defining the range of rows for which a function works. So if you take this function year or month, this year or month is returning row by row, year and month for a particular column. And these two operate at a given point in time in a single for a single value. This is what we can see. Now let us go to the next portion. We see that there is data that has to be aggregated. So let's take a function like sum. Now one should ask a question, what is the window for which this function sum works? So I have a small query which gives me sum of total due from a table called sales order header. So it should be giving me the sum of total. So for some reason, it's taking some time, but it should give me the sum of total due. Now, when it gives me the sum of total due, this sum here, which is a function, operates on all the rows of this table. That means the sum works on the window of all available rows. What is window? The range for which this particular function works. Now, this sum of total due, you can see we can use the group by clause and we can get territory wise. So here also, if you carefully notice, sum is a function which is going to aggregate the column of total due, the value in the column called total due. But this time the window is a group. That means if I take say 10 territories, for every territory, every territory ID provides a window of operation. And for that window of operation, this particular function operates. So therefore, we can see it will give me territory-wise total due. This is also an example of window. So these are things we already know. But still, we require windowing function. Why? So there are some reasons. So let us look at one of the reasons. I want to show the details and the summary together. Okay. So here I have given an example. Give me territory wise total due along with percentage total due. Percentage total due. For that, first of all, I should get what is the total amount which is due to me, and then territory wise, what is the total amount due, and then divide to get the percentage. Now, we can handle this with a subquery. So here I have taken the example of how it can be handled with subquery. Now, then what is this windowing function? It's very easy. The windowing function is using the over clause. And the good thing about windowing function is it operates after group by having aggregation, after group by aggregate first for every group, then having clause, and then finally you can see there is windowing function. So the advantage here is this function can be used to return the detailed data and the summary data together. And that is what is given in here. So you can see this particular query gives me territory ID. It gives me what is the total sales. Total due here means the total sales for every territory. Then it gives me the complete total due. What is complete total due? The total sales all over. And then I will use a calculation here to find out what is the percentage. So here you can see I am not using any subquery. So it relieves me of using subquery. What happens here? Very simple thing happens here. First, the query gets executed, and after the query gets executed, it returns a set of rows. And usually the sum will operate on either sum is an aggregate function. It either operates on the complete table or it operates in a group. But here, sum will operate over the partition or the window. You can see this is called as the window, details of which we will study later. Just wanted to give one example of a T-SQL feature. So we have seen there are so many T-SQL feature, and I wanted to show one example, the window function. Similarly, we will see what are correlated subqueries. Then we will see what are indexes and how to handle them. So SQL Server. We will also cover this part as part of indexing. We will be looking at indexing separately. Then we will see apply and cross apply. Suppose I want to execute a particular function and I also want to join the output of that function, table valued function. And once I want to join the output, like for example, I have a function which returns top 3 orders, right, for every product. So the top 3 order based on quantity, let us say. So every product I give, it will give me the top 3 orders. So this is using cross apply. And we will see that whenever table valued function is there, we will use cross apply. We will see that. We will look at merge. Merge is nothing but an upsert, update, insert. Okay, so we can merge data from 2 tables. So if there is new data, then the destination table, which is, there are 2 tables, source table, destination table. If there is new data in the source table and is not there in the destination table, it will be added. If it's old data, it will get updated. If the data is deleted in the source, the destination also, the data will be removed. So if the source table does not have a data and destination has a data, it will be deleted. Then we'll also see group by set, then with output clause, exception handling using throw, try, catch. We will see what is result set. We will see offset fetch, and we will also see how to use sequences. This is the first topic. The second topic is the physical architecture of SQL Server, where we will see the overview of how memory is managed in Windows operating system. Then we will see what is SQL Server operating system called SQL OS. We will see how memory is managed by SQL Server. The SQL Server operating systems sits between the database engine and the actual operating system. We will also see the process of disk I/O. That means SQL Server data has to be fetched from the hard disk and how it is fetched. And we'll also see the SQL Server process scheduling, how it schedules the process. So this is a theoretical part of the entire course of 30 hours. Then we will see the table and index structure. So data in table is stored in heap and in structured form. There are two options basically available. And we have the third option. We can take it as a third option. Data is stored in heap form, but has the index, which is called as non-clustered index. We will see that. So we will see what are the files, how SQL Server stores data in files, and inside each file, how we have pages, and how SQL Server data is stored in pages. Then what are the structures when SQL Server stores in data in heap form, and SQL Server stores data in structured form, ordered form, how, etc. So we will see clustered index, non-clustered indexes, right? So the structure part we will see. The functional part we will be talking about later. We will see the functional aspect in the index architecture. We will see how to maintain, monitor indexes. Then we will also see what is a file stream, how a file can be stored within a table, right? Using the file stream data. We will see that. And we will also have file table. So both options are available to store file table storage and file stream. We'll see that. Then we move to locking and concurrency, where first we will see what is a transaction. And we will see what are the important properties a transaction should have. Then we will see how SQL Server manages concurrent sessions by the mechanism of locking, and how we can have different levels of isolation between two different sessions. Blocking and deadlocks we will see. We will also see live locks. And then we will also see, when we talk about locking, we have different locks like shared lock, exclusive lock, update lock. We will also see latches and spin locks. And we will see some dynamic views so that we understand the mechanism of latches and spin lock in SQL Server. Finally, we come to the topic of query optimization, where we will see how the query is processed initially. And we will see how to read the query processing using execution plan. We will see how statistics is updated. What is statistics? So we will see that there are two types of optimization: rule-based optimization and statistics-based optimization. In rule-based optimization, based on certain rules, SQL Server will use different physical operations to get the data when we write a query. Whereas if it is based on statistics, then based on the statistics, the physical operation to get the data based on the query will be used. So statistics-based query execution, rule-based query execution. Then we will see how to understand the execution plan, starting from table seek, what is index scan, what is index seek. We will see different operators. We will see up to the level of joins. And we will see how to analyze a complex query execution plan. Then we will identify certain issues with the query, why a query can become slow. And then we will try to enhance the performance of the query by using certain techniques. And we also will see SQL Server is using statistics based optimization. It is not rule based. Therefore, what happens? There is a possibility that the plan keeps changing. But if you know for sure that a particular plan will work faster, then we can freeze the plan. So we'll see freezing of the plan and query hits. So these are the topics we will be covering as part of SQL Server Advanced. So if there is any query or if you have interest in these topics, please do uh, apply for this course, which is of 30 hours. Thank you.